Hello, and welcome to this Vicon training video. Today I'll be focusing on using the new series transform nodes available in the 3.8 version of Niagara AX. There are 3 previous training videos available for the series transform graph features. If you haven't watched the other videos yet, you may want to do so before watching this video. For the purposes of this demonstration, I am using Niagara AX Workbench version 3.8 and I'm running a station on my local machine. In the previous videos I demonstrated how to create graphs similar to this one. In this particular graph I have 2 history source components which are configured to reference the same history but for 2 different date ranges. The first source is referencing the Suite 110 KWH HVAC history for last month, which is the month of November 2013 in this case. The second source is referencing the same history, but for a period of November 2012, with a fixed date range. One of the new transform nodes available in 3.8 is the time shift node. The time shift node dialog allows configuring the relative amount of time to offset the timestamp values in the source dataset. In this case, I'm interested in performing a year-over-year comparison of the electrical consumption for Suite 110. In order to plot both datasets in the same table or chart, I need to shift the timestamps for the previous year's data forward 365 days. I've linked both the current node and the time shift node output slots to the composite node. I have configured the schema of the composite node to display the timestamp and values from each of the linked datasets. I've also linked the composite node to a rollup node to roll up the consumption data to daily records. And I linked the rollup node to the terminal node to complete the transform graph. Resolving the graph displays the collection table with all the data from the November 2013 period rolled up to daily records in the current column, and all the data from November 2012 rolled up to daily records in the baseline column. The time shift node used a positive 365-day relative time to shift the timestamps from 2012 forward by 1 year. This aligned the timestamps in the 2 datasets, allowing the direct year-over-year comparison of the data. Using the right-click Resolve Graph menu selection is an easy way to view the results of the transform graph during the engineering phase. However, it's not typically used for the user interface. It is more typical to embed the results of the transform graph as a table or chart in the PX view for the user interface. This PX view includes both the collection table view as well as the chart view. This transform graph allows us to display the year-over-year comparison, but is currently configured for fixed dates and time. It would be much more useful if the previous year component's date range automatically updated based on the current component's date range and the system time. Also, the time shift node's shift property will vary depending on the number of days in the previous month and potentially daylight savings time or leap year events. In the 3.8 version of the Vicon Pro module, we have included a range shifter component that can help achieve the desired behavior. After adding a range shifter component to the wire sheet, link the date range slot from the current node to the range shifter. Then link the time range out slot from the range shifter to the date range slot on the previous year node. I also need to link the shift slot from the range shifter to the time shift node. You will notice by default the range shifter is not applying any shift of the timestamps. The baseline period property is used to configure what, if any, offset period is to be used. The options include none, which is the default, week prior, month prior, year prior, and custom. Since I want to perform a year-over-year comparison, the year option is what I need to select. The week prior and month prior options are more applicable to performing week-over-week or month-over-month type comparisons, while the custom option could be used if you have a fixed baseline period that you always wanted to compare against. Notice how the time range out property updated to display the time range of November 2012. Also, the shift property updated to reflect the 365-day offset. By changing the baseline period to month prior, the time range out and shift properties updated as expected. Let me change the baseline period back to a year prior for this demonstration. At this point, the previous year's date range is automatically updated based on the current year's date range and the configured baseline period on the range shifter. The time shift node's shift property is also being updated automatically. You can see the PX view is still displaying the expected values in both the chart and table. However, this transform graph will now update accordingly as the system time changes. For example, if I were to view this same report anytime in January next year, it will display year-over-year comparison data for December 2013 and 2012. This graph is compositing two submeters for the suite into a combined data set. Notice the schema of the composite node includes the values from both sources. The filter node is another new transform node available in 3.8. The filter node allows injecting a predicate into the query to filter out specific records. For example, perhaps I only wanted to view data for on-peak electrical usage in my report. In the filter node dialog, clicking the plus symbol allows adding items to the predicate. The field editors are populated with the defined schemas from the node which is linked to the filter node. The filter match criteria property is used to configure the logic to evaluate the predicate items. Selecting match any configures the logic as an OR statement, meaning only one of the filters needs to evaluate to true for a record to be included. Selecting match all configures the logic as an AND statement, meaning all the filters need to evaluate to true for a record to be included. The filter node dialog may not allow selecting the necessary items. It is also not possible to configure complex logic for the predicate items. Using the property sheet view of the filter node, I can enter predicate items that are not selectable in the previous dialog, and I can also create complex logic statements. In this case, I need to exclude any records for Saturday and Sunday. I also need to exclude any records exclusive of 8 a.m. to 5 p.m. I'll also add a rollup node to the graph and configure it for a daily rollup interval and include both the HVAC and lighting schemas. All graphs require a terminal node, which can be used to configure the order of the data schemas in the resulting collection table. Notice in the resolved graph that there are now only 21 rows, and the rows which have been excluded are for Saturday and Sunday. Looking at the chart, it is now very obvious the weekend days have been excluded, and the totals are lower because of excluding the off-peak hours. I modified the collection table order to emphasize the excluded days as well. Instead of displaying the raw timestamp, I have formatted the timestamp to only display the date portion, and I've added another column to display the day of the week. The results of the transform graph are piped into a subsequent BQL query, in which I formatted the timestamp. I also included the other data schemas defined in my transform graph. Transform graphs serve as templates to define data sources and to configure graph nodes which manipulate the data for reporting purposes. The data manipulation includes combining data sources into single data sets using the composite node and applying functions to the data using the aggregate, rollup, and scale nodes. The addition of the time shift node facilitates comparing data from different time ranges, such as making year-over-year or month-over-month comparisons, while the filter node allows injecting a predicate into the query, which facilitates more robust exception-based reporting. Thank you for taking the time to watch this video, and stay tuned for additional Vicon training videos on other new features and changes in the Niagara AX framework.